Okay, so the first question gives you tan, and it tells you that your triangle is between 0 and 90 degrees. What quadrant is that? Quadrant 1. And it wants you to find the exact value of cosine 2 theta. Is this a sum and difference problem, or is it a double angle problem? Double angle. So the first thing I need to go do is I need to figure out what is the formula for cosine 2 theta. That is going to be straight off of your formula sheet, unless you remember the other two. There's technically 3. So what is on your formula sheet? Okay, and that is equal to the cosine of 2 theta. So that means I need the cosine of this triangle theta, and I need the sine of this triangle theta. I need to build that because I don't have those two things right now. All I have is tangent. So I need to build my triangle. That was not a good line. Where is quadrant 1? Is it A, B, C, or D? A. Okay, so I'm going to come in, I'm going to draw my triangle. I'm going to start at the center, go straight out into the quadrant, straight back down to the x-axis. According to the problem, it tells me tan is 3/4. So what is tan over tan? What is tan? What over what based on a triangle? Opposite over hypotenuse. So, or opposite over adjacent. My bad. Opposite over adjacent. Now, if you have memorized your Pythagorean triples, you automatically know right now that the hypotenuse is what? 5. If you have not memorized your Pythagorean triples, how could you find that? Pythagorean theorem. Okay. So what I'm going to do is I'm going to come over here, and I'm going to go ahead and figure out, based on this triangle, what is sine, what is cosine, and what is tangent. We already have tan, yes? So I need... Cosine's 4/5. Do you agree with them? All right. Do I have enough information now to go plug into the formula and actually solve?
Yeah.
All right. So cosine, we said, was 4/5. Sine, we said, was 3/5. What is 4/5 squared? 16/25. What is 3/5 squared? What is 16 minus 9? Can you reduce 7/25?
No. I have one question. Okay, that formula cosine squared theta minus, where do you see that? Where's that at?
On the back, there's something that says double angle formulas on the same side that you have the unit circle. Look at the top.
Oh, the A is theta.
Yeah. Keep it. Jacoby said that, oh, there's on the formula sheet, there's an A instead of a theta. Guys, keep in mind, that's just a variable. It can be changed out. We can use A, we can use B, we can use X, we can use theta. It doesn't make a difference. Number 2 says use sum or difference identity to find the exact value of cosine 255. With it telling you use sum or difference, that means 255 is not on the unit circle. We need to find two angles that either add to 255 or subtract 255. 135, 120? Okay, 210 and what? 45. There's another one. You can use 225 and 30. You can use a bunch of different ones. I'm going to use... Sure, because that's the one that literally just got called out. Great thing is it doesn't matter what combination you use, the final answer is going to come out the same. So we're going to go with 210 and 45.
Oh, that's what gives you 22.
We just picked two things that we're going to add together to 255. Okay. On your formula sheet, you don't see degrees, you see radians. So what is the radian associated with 210? And what's the radian associated with 45? Just to kind of have it here, we're not necessarily going to use that in the formula, but just to kind of have it there as a quick reference for us. I have cosine and I'm adding the two angles together. What does that formula look like? What was the sign in between? Minus. Because with cosine, it wants to be a little problematic and throw you a curveball. Well, what's A and what's B? With addition, does it matter what order you put these in? No. With subtraction, does it matter what order they go in? Okay. So I'm going to come through, and anywhere I see A, I'm going to plug in 210. Anywhere I see B, I'm going to plug in 45. Can you find the cosine of 210? Yeah. What is it?
Negative rad 2, net rad 3.
Negative what?
Rad 3 over 2.
Okay. Whoever's giving me rad 2 over 2, you're looking at the wrong thing. So one more time. The cosine of 210.
Negative rad 3 over 2.
What about the cosine of 45?
Rad 2 over 2.
Yeah. What about the sine of 210?
Negative 1.
What about the sine of 45?
Rad 2 over 2.
Remember that cosine is the x value, sine is the y value. What's my next step here? Actually do the multiplication. So I can multiply these two together, I can multiply these two together. When I multiply these first two fractions together, what do I get? Negative rad 6 over 4. And what about these other two? Guys, I've got minus a negative. What is that going to turn into? A positive. And both of these fractions have the same denominator, which means I can do what? So I've got negative rad 6 plus rad 2 over 4. Remember that with sine and cosine, when you're doing sum and difference, all your answers are pretty much going to look the same. Okay, you're always going to have a rad 2, a rad 6. The denominator is always going to be 4. The signs are going to be changing. The order is going to be changing, but it's not a big deal. What's another way that you might see this answer, though? You might see rad 2 minus rad 6. Okay, so don't freak out if you were to solve the whole thing and you don't see this, but you see this. They're the same thing.
I did the 135 and 120, but I didn't get that.
You should. So I'm going to take a look at yours later. Okay. Number 3 says, using sum and difference identities, verify the following trigonometric expression. Remember, with verifying, we're making sure one side equals the other side. Which side has more for us to do? The left has way more for us to do. Okay, I'm looking at the difference of sign. I've got sign and I've got an A and a B with the subtraction. So what does that formula look like when I'm doing the difference of sign? Good. And that is all going to be equal to cosine of pi over 3. If this does in fact verify, which I'll go ahead and tell you, it does. Okay, we're not going to give you something that doesn't verify just because it gets too complicated. Am I able to figure out the sine of pi over 2, the cosine of 3 pi or pi over 3?
Yes.
Okay.
1.
The sine of what is 1?
Pi over
Or
3.
sine of pi over 2 is 1? Okay.
1/2. 0. Rad 3 over 2.
Well, what do you know when you multiply by 0?
0.
So that is unnecessary. Okay. So this side is 1/2. What is the cosine of pi over 3?
1/2.
1/2?
That's crazy, son.
You just wanted to hear your voice, didn't you?
Yeah. On the video, you're like, oh my god.
All right. So when you look at number 4, it asks you to simplify, which means you continue substituting one thing for another until you get down to a single term. We've got a fraction, so when we were working with fractions and simplifying, we started this last unit. We said, let's break it up. Let's work with the top and get it done, and then let's work with the bottom separate. Which one looks like what we've been doing lately? The top. The top looks like what we're doing lately. It is the sum of sines. So I need an A, I need a B, and I need to start plugging it in. What's my A going to be? And my B? Okay. What is the formula that I'm going to be plugging into? Go ahead, say it loud.
Plus cosine is sine cosine.
Okay. Well, we can't do anything with sine and cosine of x. Those we can't substitute anything for, we can't evaluate, so they're just going to hang out. But do we know what the cosine of 90 and what the sine of 90 are? Okay. What is the cosine of 90?
0.
Are you guys fine if I just kind of come in here and do this? What about the sine of 90? So I've got sine times 0, or sine x times 0, I'm sorry, and cosine x times 1.
Cosine x.
Yeah, why is cosine x what is left?
Because 0, anything else out there, cancel out.
Yeah, these two things, the sine times the 0, that would cancel it out. So that whole thing up top just comes down to cosine x. What about the bottom? We've worked with things that look like the bottom before.
Cosine squared.
Cosine squared x, what identity is that? Pythagorean. Okay, according to Pythagorean identity, 1 minus sine squared x is cosine squared x. All right, I heard somebody say keep, change, flip. Remember, keep, change, flip is when we're doing fraction divided by fraction.
No, no.
Can you simplify?
You can simplify this.
So you would cancel out.
You would cancel out some. I'm going to rewrite this in a different way so that it's a little bit more obvious about what you cancel
You're
out.
gonna write it. You're gonna write it twice on the bottom. Yeah, she's gonna do cosine.
Okay? So I'm hearing somebody say 1 over cosine. That's because they figured out that one of these cosines on the bottom cancels out. Now, when everything up top is gone, we still have 1 left. Okay, when you cancel everything out when you're multiplying things, there's still a 1 left. So this is 1 over cosine. Do you remember what we could rewrite as 1 over cosine? Secant. So this whole mess is just secant. All right, find the exact answer for sine negative 1, or yeah, negative 105. Is negative 105 on the unit circle?
No.
Guys, you cannot use negatives to put together. Like, you can't do negative 60 plus negative 40. You can only use what's on the unit circle. So I need two things, and if I need a negative, am I going to be adding or subtracting? I'm going to be subtracting. So I need two numbers that when I subtract one from the other, I get negative 105. I'm hearing 30 minus 135. Plug that in the calculator real quick. Make sure 30 minus 135 is in fact negative 105. Just to verify. I know that sounds stupid, but just to make sure. Okay. So, am I using the sum of sign or the difference of sign? Different. So what does that formula look like?
Sine
30 is A, 135 is B, so sine 30.
times cosine 35
Okay, keep going.
minus cosine 30 times sine 35.
All right. Can we figure out what the sine of 30 and the cosine of 30 and the sine of 135 and the cosine of 135 is? What is the sine of 30?
1/2.
What is the cosine of 135?
Negative, right?
And you're getting all of this from your unit circle. What is cosine of 30?
Right, 3/2.
Right, 3/2, good. And what is the sine of 135?
Right, 2/2.
All right. I'm going to go straight into our multiplication. The parentheses? Rad 3/2. Go to your unit circle, look up 30 degrees, and pull the x value. All right, so let's do this multiplication. And we get what? Isn't it negative rad 2/4?
Minus rad 6/4. Then combine it.
Okay, so I've got negative rad 2/4 and minus rad 6/4. We can combine these into do what? Into what? What is another way that you might see this answer written?
Negative rad 6 minus rad 2/4.
Okay. I just want to make sure that if it was a multiple choice problem and this wasn't there, but this was, that you would know that they're the same thing. Given the cosecant of A is 25/7, we'll stop right there, guys. We have not been working with cosecant, secant, or cotangent. We've been working with sine, cosine, and tangent. But what do I know about cosecant? It's the reciprocal of sine. So if cosecant is 25/7, what is sine?
7/25.
Okay, good. And pi/2 is less than or equal to A is less than or equal to pi. That means that triangle A has to happen in which quadrant? Good. And what's negative in the second quadrant? X or Y? X. So my cosine is going to be negative. Find cosine 2A. All right, let's draw this triangle real quick. You said second quadrant. I'm going to go back to the green. Straight out. Back down. Oops, that should be right triangle. I know that the sine is 7/25, so sine is what over what? Opposite over hypotenuse. So here's the 7, here's the 25. If you know your Pythagorean triplets, you already know 24. But because we're in the second quadrant, we know that the cosine is negative, so that x value is going to be negative. That's the whole reason you have the quadrant, is to figure out what's negative and what's positive. So let's come over here real quick. We already know that the sine is 7 over 25. What's the cosine? Negative 24 over 25. And what's the tangent?
7 over negative.
All right. What formula do you have on your formula sheet already that you didn't have to memorize anything like that? Already on your formula sheet for cosine of 2a.
Cosine squared theta.
Minus.
And again, you see here, we'll do A's just to okay, so we fixed that. Now you have A's instead so that we're being consistent with the problem. So what did we say the cosine was?
Negative 24 over 5.
And what sign?
7 over 25.
Negative 24 over 25 squared. You can use your calculator on the set.
576 over 625.
576 over 625? It's not, yeah, because when we squared that negative, it turned positive. Okay, and then 7 over 25 squared?
What'd you say? 49.
49.
No, yeah.
She tweaked that.
All right, and the final answer. Man, if only you had this magic device to plug it into. 527. And is that going to be something that reduces? Do you remember how to tell in your calculator? Okay. Those of you that don't remember in your calculator, if you plug this fraction in, so 527 divided by 625, get the decimal, then hit math, enter, enter, it'll give you another fraction. If it gives you the exact same fraction you plugged in, then this doesn't reduce. If it gives you a different fraction, then it does. So just verify that it does not reduce for me real quick.
No, it doesn't really.
It doesn't reduce? All right. Find the exact value of cosine A minus B. That's the formula that we're going to be plugging into. So tell me what that formula is real quick before we do anything else. Say what is this again? Plus. Okay. Just to go ahead and have that formula so I know what I am going to be working with. Given that cosine of A is negative 15 over 17, and that A is between pi and 3 pi over 2, so what quadrant is triangle A going to be in? And sine B is 4 over 5, where B is between 0 and pi over 2. What quadrant is 0 and pi over 2? First, quadrant 1. So we were having some major issues with these types of problems in the notes, on practice, and on the quiz. So that's why there are, I believe, 2 on your test review. 1 on your test review. Okay, so that would mean that you should be looking at 1 on the test that you have to do. So let's draw our triangles. Let's start with triangle A. What quadrant did you say triangle A was in? Third. The third. Okay, so I am going to go straight out into the third quadrant, straight back to the x-axis to create my triangle. This is my triangle A. And I was told that the cosine of this triangle is negative 15 over 17. Cosine's what over what? Okay, which one's going to get the negative, the adjacent or the hypotenuse? The adjacent. Okay, the hypotenuse is never negative. If you know your Pythagorean triples, we already know that other side. 8. And what do we know as far as the sine of that side, considering we're in the third quadrant? Good. Those Pythagorean triples are going to help you if you know them. Now, if you don't know them, what could you do to find that 8? Yeah. You have to keep in mind the signs based on the quadrant, though, because Pythagorean theorem, when you solve for it, it's just going to tell you 8. You need to know it's a negative 8 because it's in the third quadrant. What about triangle B? What quadrant do we say triangle B was in? The first. All right. Straight out, back down. Triangle B. What information do they give me that would help me label triangle B? Okay, and sine is whatever what? Opposite over hypotenuse. If you know your Pythagorean triples, what's the third side? Good. Okay. So looking at triangle A, we're going to start filling in here. I want the cosine of A, so I'm going to come to triangle A. What's the cosine of A? And they actually already gave me that in the directions. What about the cosine of triangle B? Go over to B, 3 over 5. What about the sine of A? And the sine of B? All of those things, that's why we have to build the triangle, because we have to be able to pull the sine, cosine, and tangent. Some people, as soon as they draw the triangles, will go ahead and put, like, cosine is negative 15 over 17, sine is negative 8 over 17, and tangent if they were to need it. And then they come over here and they say that cosine is 3 over 5 and sine is 4 over 3. That way, when they go to plug it in, it's already done. That's fine. I'm cool with that. Okay. What are we going to handle at this point? What's our next to last step? Multiply that, multiply that. Negative 45 over 85. Thank you. Now let's put those together. It doesn't simplify, is that what I'm hearing? Yes. Okay. Okay, verify that sine pi over 2 minus theta equals cosine theta. I am working with what? Some difference, sine, cosine, tangent. Difference of what? Difference of sine. So what does that formula look like? Sine A, and we said that A was pi over 2, times cosine B, and B is what? Theta. Minus cosine A, and A is pi over 2. Sine B, and B is theta. Guys, one of the issues I am having with you as you are going through your quizzes and even on the last test, when we do verify, you need to have it equal to something. Simplify is the one that's not equal to something. Verify needs to be equal to something. So as you do your work, you're going to keep saying equals cosine theta every time, so that at the very end you have cosine theta equals cosine theta. Okay? What am I going to do?
So sine pi over 2 is going to become 1.
Okay, sine pi over 2 is going to become 1.
And then you just drop down cosine theta.
Drop down cosine theta. Why am I dropping down cosine theta? Why can't I evaluate it?
Because there's no theta on the circle.
There's no theta on the unit circle. Okay? All right, I'm hearing the sine theta is going to cancel out. Why? Because when you multiply something by 0, it is gone. So I now have 1 times cosine theta, which is? Cosine theta equals cosine theta, and I am done. Using the Pythagorean identities, what we did last unit. Find 2 ways to write the double angle formula for cosine other than the one that's in the formula sheet. Show all steps. So there's going to be 2. So what I'm going to do is I'm going to divide this in half real quick. And on top of both of them, I'm going to write what it gives me. And let's say that you don't remember the Pythagorean identities at all. They're on the formula sheet. Flip to the front of the formula sheet. And there are 2 formulas, one of which says sine squared equals blank, and another that says cosine squared equals blank. Do you see them?
Yeah.
No. Pythagorean identities. Right there. So one says sine squared theta equals 1 minus cosine squared theta, and the other one says cosine squared theta equals 1 minus sine squared theta. Those are what you're going to use to plug in here. So instead of cosine squared theta, I am going to say what?
1 minus sine.
1 minus sine squared theta, or x in our situation. And we'll go ahead and finish up this one. Guys, would I say minus sine squared theta twice? No. What would I say? Minus 2 sine squared theta, or x. So I've got 1 minus 2 sine squared. There is one of your other double angle of cosines. That's one of them. What do you think I'm going to replace on this one?
Sine.
The sine squared theta. And what am I going to replace it with? Now you've got a minus sign in front of the parentheses, so what do you know is going to happen with that minus? Distribution. So this one kind of has one extra step, not a big deal. Okay. Is that the simplest way to write this, or is there something else I can do?
You can combine the cosine squared.
I can combine the 2 cosine squareds to be this is your other one. So there are your 2 double angle identities for cosine other than the one that's on the formula sheet. Remember, they're not given to you because we talked about how to produce them. You just saw how to produce them again. It's on your test how to produce them. Okay, last one. Which side we're verifying? We've got something equals something else. Which side has more to do?
The right.
The right.
The right.
The right has way more to do. Now, how would I go about multiplying this to
Oil. Oil it.
You could do foil or you could do box. I am going to foil because it takes up less space. If you box, go for it. Not each other, just this. First, outer, inner, last. Foil. Cosine x times cosine x.
Cosine?
Cosine
squared.
Cosine x times negative sine x.
Minus cosine x times
Sine x times cosine x.
plus cosine
Sine x times negative sine x.
minus cosine squared.
Okay?
Cancel out.
Why do the two middle ones cancel?
It's a negative.
It's the exact same value, but opposite
But
sign.
opposite symbols.
Okay, so what am I left with now?
Cosine squared x minus sine.
Take a look at your formula sheet. What is cosine squared x minus sine squared x equal to?
Cosine 2x.
1.
What?
Oh, I'm looking at the wrong one.